Braxton Pulley is up next. His presentation is on the beginning of life. That's all I'm going to say. Here you go.
Thank you very much. One of the things that has been fascinating me quite a bit is just how far science has come in understanding where life has actually come from on this planet. The process is just amazing. It's absolutely incredible about what is going on and what we know, and this information is not necessarily getting out there. For a very long time, when you started discussing life on Earth, the only real place that you could get answers was religion. This idea that it was magical. And that was often what was used to describe things that we didn't understand. For example, rain, eclipses, earthquake, an angry God. And that was life, is that clearly life is a miracle. It must come from life, or from God. Well, science has come a really long way in understanding what is happening. It is taking a lot of the mystery out of what's going on in our world. And this is not here as to explain away religion or anything like that. This is just talking about an observation of our natural world that we live in. And one of the challenges about explaining life on Earth, how it started, is how we went from inorganic to organic. In other words, how did chemicals that are not alive become something that is alive? That is the mystery. That is the big question about how do you see an increased complexity in the world that we live in. Now, it used to be that through the 20th century, they thought that in old times, back when the Earth was brand new and this primordial soup hit by lightning and heat, that it would create life. And now they have found it does create organic chemicals, but it was not able to create the complexity that we were looking for. There was more to it than that. It was just not able to take us that final step. And that's where astronomy came in. And when they started to really understand how the universe itself and how the stars above us really affected it. But to get that idea, we have to take it way, way back into the beginning here and talk about the basics, the elements. Right after the Big Bang, what happened is that hydrogen was the very first element to coalesce out of this mist of matter. But it's just a simple atom. It does not explain the complexity that is us. So what had happened is that enough of these hydrogens formed together, and they started creating stars. And as those stars got massive enough, an interesting thing happened. Through heat and through the process of pressure, nuclear fusion started to occur, and these atoms started connecting to each other. And we started creating more elements, helium and so on and so forth. And it went up to the point where even most stars can create up to the first 6 elements. And carbon is really interesting on that because they have found that some of these dormant dead stars out there are actually, what's left of them is just a solid diamond that's larger than Earth. Can you imagine that? That's one heck of an engagement ring. But it doesn't answer how do we get the bigger ones. Well, to get bigger elements like gold, platinum, so on and so forth, you need to have bigger stars. And as you can see up here, our sun versus Arcturus. This is our planets versus the sun, and then our sun versus Arcturus. That's the size of a planet you need to get some of these different elements. And that's how you started creating all these different things. But the bigger stars are more rare, and that's why gold and platinum are less frequent than carbon. But it's still raising questions. How did they get here? How is it that the life is still inorganic to organic? We have not addressed that or answered that, but I just want to give you an idea where elements come from. But something to keep in mind as well about our solar system is everything here, Earth, Moon, Sun, are all the remnants of dead stars. So as a star explodes, it's left with all this gunk left over, and that through gravity coalesces into our solar system. But something really interesting happens on the big stars. It's really, really fascinating. When a big star explodes, it actually creates organic chemistry, which is amazing because it used to be that we thought only a living thing could create organic chemistry, but a dying star can as well. And we know this because we're finding amino acids, which are an organic chemical, in asteroids. Not on our Earth, in asteroids, an organic chemical in asteroids. We're also finding gold and platinum and so on and so forth. So as our world was created from the dust of dead stars, and it's being seeded by the 20 million meteorites that hit our planet every year, it's being seeded with these heavier elements, with these amino acids and so on and so forth. And what happens from that is that that old idea that we had about the primordial soup and the lightning, now we have all of the elements you need for life already here on Earth. All of the elements there, the amino acids. So now you take the same experiment with heat, lightning, the primordial soup, and pre-existing amino acids, and now you get more complex molecules. And in fact, they speculate that the first living molecule looks something like this. This is an ancient form of a nucleotide, which is called RNA. And it's just a combination of a bunch of different amino acids, things that were already here and melded together through the pressures of our early Earth. From that, once you had the RNA, it was able to self-replicate as a natural process of that protein. That's it. And from that, those that could self-replicate were able to persist. Those that did not self-replicate were destroyed. And as they were exposed to more of the Earth's atmosphere, they continued to develop and evolve. Now the thing is, that's life, that's how it happened here. And this in no way devalues religion or anything like that. Just like understanding how an eclipse works, which back 4,000 years ago was an act of God, now we just know it's the moon getting in the way. Understanding how life started here does not negate religion. But one of the things that's really cool from this is that if we were seeded by the deaths of stars, it is a statistical necessity that other planets have been too, and the likelihood that life is elsewhere is very, very high. Thank you very much.